Hello students, this is Sir Murtaza and welcome you to another lecture of physics. So as we are studying chapter number 2, so here also we are continuing our chapter number 2 with some more SLOs to cover. So the agenda for this lecture video for today is we are going to discuss the following SLOs, and that SLO is 2.7.2, in which we will be determining the magnitude and direction of a force from its perpendicular components. Previously what we have learned is whatever we have learned, this SLO is its opposite. Okay, previously we have been given a force F and we have resolved it into its rectangular components, which is Fx and Fy. So with the help of force F, we have find a formula for Fx and Fy. Okay, but in this SLO, what we are going to do, we are going to determine the magnitude and direction of a force from its perpendicular components. So it means that we will be having a perpendicular components, which is definitely Fx and Fy, and with the help of those perpendicular components, what we are going to do, we are going to determine its magnitude and the direction of the force. Okay, so let's look forward. Okay, determine the magnitude and direction of a force from its perpendicular components. So here again, I'm going to show you a diagram. First, we will look onto the definition. Since a force can be resolved into two perpendicular components, its reverse is to determine the force knowing its perpendicular components. Okay, so as I have mentioned before, it is the opposite of the SLO that we have done in 2.7.1, which is our previous lecture. Okay, now here is the figure. Okay, so I will advise you for a moment, just pause the video and draw this figure onto your copy. Okay, because whatever we are going to do, we are going to derive a formula and we will be continuously referring to this diagram. So if this diagram will be in front of you, it will be very helpful for you to understand this derivation. So I need you to pause the video for a moment and draw this diagram on your copies. Okay, hope you have done this. Okay, now move forward. Consider Fx and Fy as a perpendicular components of a force. Okay, what we have done here, again we have x-axis, we have y-axis. Okay, and this is a force, and this Fx is its x-axis component. Okay, and this Fy is its y-axis component, and this force F is its resultant force. Okay, now what we have done is, I have to shift this. Okay, now what we have done this, the perpendicular components is represented by lines OP and PR respectively, as shown in figure. Now according to head to tail rule, OR is equal to OP plus PR. Okay, so I'm referring you to this again. This is OP, this is PR. Okay, and this is OR. So OR is the resultant force, OP is its X component, and PR is its Y component. So this is the same thing that have been written here, and according to head to tail rule, OR is equal to OP plus PR. Okay, the vectors are added with head to tail rule. The head of the first vector is joined with the tail of the second vector. Now what is being shown, thus OR will completely the force whose x and y components are fx and fy respectively. That is, f is equal to fx plus fy. Okay, this is the same thing, the thing we have done previously, that we have replaced the lines with fx and fy. Okay, then the magnitude of the force F can be determined using the right angle triangle OPR. Okay, here again, what we are going to do, just remember the SLO, we are interested in finding the magnitude of the force, and in order to find the magnitude of the force, we will look onto a right angle triangle OPR. Okay, and we will look onto another trigonometric ratio. According to Pythagoras theorem, hypotenuse square is equal to perpendicular square plus base square. Okay, then we can replace hypotenuse by f, perpendicular by fx, and base by fy. I'm just drawing a rough diagram here, just to make you understandable. Okay, this was figure like this. This is hypotenuse, and this hypotenuse was represented by force F. This is perpendicular, and this perpendicular side is represented by Fy. You can refer to the diagram that you have drawn in your copy, on your copy. And this is base, and you can write base as fx. Okay, so we have replaced hypotenuse by f, perpendicular by fx, and base by fy. There are squares, so you can put squares on these values. Then you have learned one thing in maths, that whenever you remove a square from here on the other side of the equation, what you can do, you can put a square root, or you can understand it by like this, that taking square root on both sides. So when you put square root here and when you put square root here, okay, what happens is from this square, this square root cancels, okay, and this remains the same. So f square becomes f, and this value comes in the square root. Okay, so by taking square root on both the sides. So this is the formula. Again, you have to remember this formula. The formula is f is equal to square root of fx square plus fy square. With the help of this formula, you can find the magnitude of a force whose x component and y component is given. Okay, now we are going to look on to the direction of force. Okay, now the direction of force, x-axis with x-axis is given by, the formula is tangent theta is equal to perpendicular upon base. Okay, what I have told you, for trigonometric ratios we have to remember sine theta, cos theta, and here I have shown you tangent theta. Okay, so the formula for tangent theta is perpendicular upon base. As it is a trigonometric ratios, so it is showing the ratio between the sides, and which side, perpendicular upon base. Okay, then what we can do, we can replace perpendicular by fx and base by fx. Okay, by looking onto the diagram, which is the right angle triangle. Then we have to find theta. So this is tangent. When tangent goes to the other side of the equation, it becomes tangent inverse fx of fy upon fx. So this is the formula. Okay, so here we have learned two things: the magnitude of the force, which is f is equal to square root of fx square plus fy square, and the angle, which is represented by theta. The formula is tangent inverse theta is equal to tangent inverse fy upon fx. Okay, so this is it. In this way, you can find the magnitude and the direction of a force whose rectangular components are given. Okay. Now, just before ending, I want to show you all the formula that I have told you before. I have told you a short method, a word or a sentence you can remember in order to remember the formula sine theta and cos theta. Some people have curly brown hair. Okay, so in order to understand, to remember the formula of tangent theta, you can complete this sentence. Okay, how? The formula is sine theta is equal to some people means p, have means h. Okay, this is sine theta is equal to perpendicular upon hypotenuse. For cos theta, curly brown, browns b here. Okay, now for tangent theta, the word is still printed black, okay, upon b. So I will repeat the sentence for you. Some people have curly brown hair till printed black. Okay, so in this way you can understand, you can remember this formula, which is sine theta is equal to perpendicular upon hypotenuse, cos is equal to base upon hypotenuse, and tangent is equal to perpendicular upon base. By remembering the word, some people have curly brown hair till printed black. Okay, so this is it for this lecture video. We are done with this, and inshallah we'll meet very soon in our next lecture video, and hope you have understood all the topics or the correctly and correctly. So now I'm here to say Allah Hafiz to you. So I'm stopping this video. Okay, so Khuda Hafiz.